Okay, chapter 3.5. Today I'm passing out your guys' notes. Okay, the first thing you guys need to know is that we're going to be talking about PERT again. And we're going to do applications problems with PERT, okay? PERT is our continuously compounded, right? So P is still going to be our principal. E is still our number 2.718. The rate is still going to be your decimal that you have to change from a percent to a decimal. And time is still going to be our number. If it's 40 years, 10 years, whatever it is, you're going to put that number in there. And A is our balance. Okay, now our goal is, though, what if I wanted to double or triple my money? So let's say I invested money, $500, and I wanted to know when I was going to double it at a certain percentage rate. You with me? So here's the thing. It doesn't matter how much money I have, okay? It doesn't matter how much money I have. It's how long will it take, okay? So if I go back to this formula, A is equal to PERT. What does A represent in this formula? The balance. And I need my balance to be what? Double the amount that I put in. Well, how much did I put in? How much did I put into that formula? P is how much money I put into my account. Would you agree? So if I want it to double, how much money am I going to have? 2P. So this is going to be 2P is equal to PERT. Would you agree? Well, what can you tell me about your P's there? The P on the left side and the P on the right side. What's going to happen to those quantities? They're going to cancel out, right? So if those cancel out, I'm left with 2 is equal to ERT. Now, that's kind of funny for the simple fact that when it comes down to it, from there, I can say, do I know the time or do I know the rate? You with me? So let's say I always know my rate. Well, how do I find my rate? This is the formula you want to work with always, but now how do I find my rate? Well, how do I get rid of an E? Log base E, which is what? The natural log. So if I take the natural log of both sides, you're going to have the natural log of 2 is equal to R times T, divide by R, and you're going to have that the natural log of 2 divided by R is equal to the time it's going to take to double. Make sense? That's the time it's going to take to double. It doesn't matter how much money I put in because the P's are always going to cancel out. So what about to triple? Isn't it going to be the same concept? It's exactly the same formula, but instead of having a 2 there, I'm going to have a 3. Okay? So I'm going to have 3P is equal to PERT. So 3 is equal to ERT, which means now I'm going to have this formula that whenever I solve, it's the natural log of 3 divided by R is equal to T. If I wanted to quadruple, natural log of 4. Do we all understand that? Yes? Okay, so that's how you are able to find out how long or what interest rate you possibly need to be able to quadruple or to double or triple your money. Any questions over that? Okay, good. Let's go ahead and do an example of that. So I give you your initial investment. I give you your rate. I want to know the time it takes to double your money. And then I also want to know the amount that you're going to have in your account after 10 years. So how do I go about doing this? Well, I need to know what I know. What is $20,000 going to be in this case? What letter? And whenever I say what letter, I'm talking about in this formula. So P is equal to the $20,000, right? What's the rate of 10.5% going to be? Very good. So my rate is going to be 10.5%, which is going to be 0.105. Yes? Okay. Now it says it wants to know the time it takes to double. That's just 2P. But we already said it's 2 is equal to e to the r to the t, yes? And we already know that this is going to be the natural log of 2 over r is equal to t. We already know that from what we just did last slide, correct? So all I have to do is plug in my rate. So the natural log of 2 divided by 0.105. And if I come over here to my calculator, and I open a calculator page, this is going to be control division key. The natural log of 2 over 0.105, and that's going to give me 6.6. What does that 6.6 represent? It's going to take me 6.6 years to double my money. Is that kind of helpful to know if you're giving a big chunk of money away and you want to know, man, how long do I have to stay away from this money before it's going to double and that I have accessibility to it? Is that a skill or a concept that I need to know and would like to know to be able to do successful in my finances? Right. Make sense? Okay. Now, the next one is I need to know the amount after 10 years. The amount after 10 years. Well, you're just going to use PERT, but I know it's going to be $20,000 e to the 1.05, and I'm going to put a 10 there. Yes? Did we get that? Okay, so if I come back over here to my lovely calculator, $20,000 e to the 0.105 times 10. So how much money will I have? $153. So after 10 years, that's how much money I'll have in my account. Do we all understand that? Yes? Right. I want to get a 10.5% rate as well. Any questions over that? We good? Okay. That brings us to the next concept right here. I just want to know my initial investment. So I already did one on how to double. Would you agree? So I'm not going to do the double. You already know how to do that. How do I find my initial investment? I do. I need to know what I understand here. So P, I don't know. That's going to be P. This is a question. My rate is going to be 0.02. And my amount after 10 years, do I know that? That's going to be $2,000. Do we see that? So I put down all 4 letters. So if I plug that in, I'm going to have $2,000 is equal to P, I don't know, E is 0.0, rate is 0.02, and my time is 10. What do I know this to be right here? What type of a calculation is that? It is an exponential function, you're correct. But is it e to any number? Isn't that just a number? Because e is just a number, would you agree? So that's just a calculation that's a really big calculation, right? So if I want to solve for p, all I have to do is divide both sides by this jump, right? So if I go back over to my lovely little calculator and type in 2,000 is how much money I have left, I'm going to divide that by e raised to the 0.02 times 10 and hit enter. How much money did I start with? $1,637.46. How much did I say that was? Now, let me talk about this a moment. Is this a good investment or a bad investment? It's terrible, guys. This is a 2% interest rate, and you're leaving your money in a savings account or a checking account because that's as much as most savings and checking accounts give you at a local bank is 2% interest. I'm giving them $1,600, and in 10 years, they're only going to give me what? $63 back? Is that cool in 10 years if they only give me $63 back? Oh, I'm sorry. I'm losing my mind. I was going up to 1,700. Sorry, but good call. Mrs. Yoder's losing her mind. Okay, but still, that's only like close to $400. Do you want more than $400 over 10 years? I want more than $400 over 10 years. Would you agree? Okay. All right. Now, this is how you guys are going to do problems 1 through 8. Any questions on problems 1 through 8? Problems like 1 through 8, okay? You can pass on. Okay, that brings us to the next concept. This brings us to the next concept, which are isotopes. Isotopes, come on, put your science brain on. Okay? Same exact formula, okay? It's how long is an isotope in your body. Like if you can go and have a scan done and it requires contrast in your body, you with me? That's a chemical that they're putting in there so that whenever you go and they put you in that nice circular thing, that it's lighten up your body on the inside whenever those images are being, and they're able to take pictures of your body. Well, and then after you get done with the CAT scan, they always tell you, hey, you need to make sure you drink a ton of water. Well, the reason why they want you to drink a ton of water is to flush that dye out of your system, that contrast. Well, this question right here is asking you, how long will that isotope or that contrast stay in your system if they've injected this much into your body? You with me? So it's exactly the same concept as PERT. So Q of T is going to be your balance or what is left of the isotope. Okay? C is the initial amount of the isotope that they placed into your system. R is the rate at which it is slowly decaying or diminishing from your system. And T is the time that it will be in there. You with me? Same exact concept as investing money, yes? Okay, so with that being said, let's go ahead and go here. A half-life. Half-life, instead of doubling our money, we're talking about decay. You with me? So we want to know how long will it take for this isotope that they've injected into your body to become half the amount in your body. You with me? So that's what we call the half-life. How long is it going to take? For example, how long will it take for radioactive material to decay? You with me? Things like that. We're talking half-life. So that means I wanted half the original amount. So that means the C's cancel out. So I have 1/2 is equal to e to the RT. So that means the natural log of 1/2 divided by R is equal to T. Same exact concept as doubling, except for now we have half. Same exact concept as what we did with the money with doubling and tripling, except for now we have half. Okay? Do we all understand that? So I give you this isotope 22Ra or 226Ra. Do we really care what the isotope is? I'm a math teacher, I'm not a scientist. So for this means nothing to me. If I was in science and I understood all of that, it would mean absolutely something to my brain. Okay? But for me to do the math problem, it's not relevant. Do we all understand that? What is relevant is how many years it takes for my half-life to happen. Half-life means, I have to go ahead and I have to use this formula, right? That's the formula I have to use whenever it says half-life, yes? It's PERT with a C, where C is going to be the initial amount of the isotope injected. Patience, grasshopper. Okay, so we already know this is the natural log of 1/2 is equal to RT. We already know that. And this is going to be 1,600 years. That is going to represent what here? The T, right? So the natural, that represents the years. That's not the rate. So that's 1,600 is the rate times the rate. Okay? I need to know the rate at which this is decaying or leaving your body. Do we all understand that? If I don't have a rate, I cannot do this. Do we understand that? So I need to go ahead and find this out. So I'm going to take the natural log of 1/2 divided by 1,600, and that is equal to my rate. So if I come back over here to my calculator, and I'm going to go ahead and have the natural log of 0.5 divided by 1,600. Do you see that that is, why is it negative? It's decreasing. I am decaying. I'm slowly going to be losing the isotope within my body, so my rate must be negative. Do we all understand that? So I'm going to have 3 zeros and then 433. And you really do want to keep this rate there. As long as you possibly can. Do we all understand that? Yes? Okay. Now you need that decimal there because we want that for accuracy. Now I want to know how much do I have after 1,000 years? Well, that means I have to go to this. Q of t is equal to cert. Q of t is how much is there. That's my balance. Do you agree with me? It's the same thing as PERT. It's my balance. And that's what it's asking for, the amount after that, right? Well, here's the thing. What was my initial amount that I started off with that was injected into my body? It's 10 grams. It's right there. That's the initial amount. This is your C at T, or your C of T, yes? That's your C. So you're going to go ahead and put 10e to the 0.0000433, and then this right here represents my time, 1,000. Do you see that? So if I come back over to my calculator, I'm going to go ahead and put 10e. I'm going to arrow up and grab that times, what was that, 1,000? I'm going to enter. So how much of this isotope will I have left after 6.48? After, sorry, 1,000 years. What's the 6.48 represent? It changed it to scientific notation. It changed it to scientific notation so the calculator could do it easier. And that's actually pretty darn cool. Okay, so 10 is the initial amount. This long, crazy number right here, the negative 4.333, that's the rate at which it's declining. The 1,000 is how many years, and this is my balance that I have left after 1,000 years. So I have 1,000, after 1,000 years, I have 6.48 grams of the radioactive material or the isotope, right? Well, how long does it take it to have a half-life? So you know you have to have more than 5 grams, right? If you think about it logically, there's 10 grams total. It takes 1,600 years for me to get half of my 10 grams, which is 5. And I'm only going to 1,000 years. So it has to be larger than the number 5. Would you all agree? Okay, this is how you guys are going to do problems 9 and 10. Okay, we're going to skip down here. And if I have time, I'll come back and I'll do that other example. Okay, earthquake intensities. Earthquake intensities are pretty important concepts. Okay, basically it tells you that R is the magnitude. I sub 0 is 1 equals 1 is the minimum intensity. So if you have like an earthquake, the minimum it can be is 1. Okay, I is the intensity of the earthquake. So I sub 0 is always going to be 1, and that's what you're going to use in that formula every time. Yes, that's exactly what this is. It's like the Richter scale. It's trying to find all of that out. And we kind of did this last year in Algebra 2. You were introduced to it a little bit. And these are super duper easy. It's a plug and chug. Okay? It's a plug and chug. It says find the intensities I of the following earthquakes measuring R on the Richter scale, let I sub 0 equal 1. For the Fiji Islands in 2003, where R is equal to 6.5. So they're telling you on the Richter scale was a 6.5. Well, what was the intensity? Well, my formula that you're going to use is R is equal to log base 10 of I over I sub 0. You with me? So you just literally plug and chug. So if you're plugging and chugging, you're going to have 6.5 is equal to the natural log of 10. I is what we're trying to find, and I sub 0 is 1. Do we all understand that? I sub 0 is 1. So how do I find this whenever I'm going to have just this log base 10 of I? I need to find I. So how do I get I out of that situation? How do I write this as an exponential? 10 to the 6.5 is equal to I. So you literally Just go back over to your calculator and you plug that in. 10 to the 0.65 or the 6.5. And what is this? 3.16228 E6. What is that? What does the E6 mean? It means it is scientific notation. And since the 6 is a whole number, it's not a negative number, you're going to make this a larger number, so move it to the right. If you arrow up one time, it'll automatically grab it for you, and you can see the decimal and you can write it down. So just arrow up and hit enter, and it'll give you the decimal out of scientific notation. So 3162277, 3162277. That is equal to the intensity. Nope. Do we all understand that? Okay, and that's how you're going to do problems 15 and 16. Okay, this is populations, and it says the population P in thousands of Bellevue, Washington, is given by P is equal to 110 KT, where T equals 0, represents the year 2000. In 1980, the population was 74,000. Find the value of K and use this result to predict the population in the year 2020. Is this super helpful to know in mathematics, how to do a problem like this? It's really important if you're doing a census in your town, right? How fast is your town growing? Is there going to be a housing epidemic? Is there going to be an issue with jobs because we don't have enough jobs in the area to accommodate the number of people of our population? How fast does our city need to grow to accommodate what is going on with our population, our birth and our death rate? Those are all really, really important things. Like if you live in China, this would really be really important for certain areas. If you're living in a war area, again, something you need to know what's happening, okay? So the population P in thousands. This is what you know. This is your lovely formula. Where T represents the year 2000. Okay? Now, it says in 1980 the population was 74,000. Huh, well that's interesting. I need to know the rate at which my population is growing or declining. Do you understand that? So I'm going to use the past population of 1980 corresponding to 74,000. However, is 1980 in the format that I need to be utilizing it in? Why? It needs to be -20 because if we look at this problem, and here's the other thing, it says it's P is in thousands. So do I have 74,000 correct? What should I have there? Just 74. Do we all understand that? Okay, and the reason why it's 74 because P is in the thousands. Do we all understand that? Yes? Now, I can also talk about my initial population or measurement. We like 0, don't we? What does 0 mean? 0 represents what year in this problem? So in 2000, do we know what the initial population was? No. Yeah, we do. Think PERT. 110, right? Oh, I heard that. 110,000. Do we all understand that? Yes? So actually, I've been given 2 points of interest here. I've been given the year 1980 was 74,000, and I was given that in 2000, my population grew or very good. It grew because it went from 74,000 up to 110,000. Do you understand that? So I need to find the rate at which this thing is growing. So how would I go about that? I'm going to use this right here. So I'm going to have 74 as my balance of my population is equal to 110e to the k is going to be known as my rate. And this is going to be -20. Okay, why am I doing that? Because I want to know the rate at which this thing is growing. If I cannot find the rate, I cannot do future predictions. Do we understand that? So I'm going to go ahead and take 74 and divide it by 110. Yes? Now, how do I solve for E? How do I do that? So I need to take the natural log of both sides. And now I need to solve for K by dividing by -20 on both sides. And I'm going to get my rate. This is going to be my rate at which my population is growing or decaying. So I'm going to have the natural log of 74 divided by 110 all over -20. So my rate at which I am going to be increasing my population, how did I know it's increasing? By this decimal. Because it's positive. It's going to be 0.019821. That's my rate. Now, let's go back to my problem. Find the value K, we did that, that's my rate, and use this result to predict population 2020. Okay, so what's 2020 going to represent? Very good. So in 2020, that corresponds to the year 20. Do we all understand that? So what you're going to do here is you're going to have your population P is equal to 110 e to the 0.019821 parentheses 20. Correct? It's a simple plug and chug. So I come back over here and I do that. 110 e to the arrow up and grab that. Why? Because we're too lazy to actually type it all in. And then times 20. So that is 163.514. 163.514. Now, that's a decimal, but what does P represent? So what is that? Very good. So my population is 163,514 people. Do we understand that? So that decimal turns into a comma. Yes? Okay. And that is pretty much the rest of the worksheet. Okay. So I would like you to open your book to page 224 quickly. Page 224. There are some graphs, actually page 217. On page 217, there are some graphs on here that you need to be aware of and what they look like and how would you basically say, hey, that's an exponential, that's a logarithm, that's a bell curve. What are these? Go sit beside somebody and share a book. Okay? Steph will help you out. Okay, so on page 217, there are 6 graphs there. The first one is an exponential growth, correct? Do we see that? The next one is a decay. Notice it's going down. The next one is what we call Gaussian. It's that bell curve. Whenever we're talking about a bell curve, we're comparing and contrasting people, ACT scores, average cost, things like that. Make sense? If you are in the bell curve, that means you're average. If you're on the outsides, that means you are extremes. You're extreme ones. You are either really, really, really exceptionally intelligent, or you're on the low spectrum. Do we all understand that? So that's what we'll be talking about with IQs. Then you have a logistics model. A logistics model, it talks about viruses. So for example, we want to say, okay, Justin gets a virus, and we want to know when he comes to school how quickly it'll spread to the entire school. That's a logistics model, where all of a sudden there's just 1 or 2 people, and then phew, it takes off, and then it flattens back out again, and everybody gets sick. Does that make sense? So that's a logistics model. Then we have the natural log and the common log, where it's just a natural log. You guys know what those look like. We've already done that. So if you go ahead and you come back over here, and actually if you go through this, it shows you an example of every one of those and what they look like. Okay, so if you're on page 221, you have the Gaussian model, and that's going to be A e to the negative x minus b quantity squared over c. And if you turn your books over to page 225, it gives you problems A through 6 where you're able to just match those graphs and you are able to determine, is this a logarithm? Is this an exponential? What is this? And I just really wanted to show you the differences in those graphs and what they look like. Any questions? Okay, I will leave the answer key for you guys for tomorrow for you guys to go over this, and the answers to 3-4 are already up there, and then 3-5 will be up there later. Okay?